everyone, welcome to today's class. Today we are going to discuss about arrangements of resistors in a circuit. How we are connecting resistors in a circuit. There are two methods to connect resistors in a circuit. First one, series combination of resistors, and the second method, parallel combination of resistors. There are two methods to connect resistors in a circuit. First one, series combination, and the second method is the parallel combination of resistors in a circuit. Then you have to study more about these two methods. First of all, let's talk about series combination of resistors. Or if you look at this picture shows the arrangements of resistors in series. In series combination, we are connecting the resistors in a circuit one after other. In series combination, we are connecting the resistors in a circuit one after other. Then this picture shows the parallel combination of resistors in a circuit. From the picture itself, you can understand that in parallel combination, we are connecting the resistors between the same terminal points, and we are connecting the resistors like branches. In parallel combination of resistors, we are connecting the resistors between the same terminal points, and the resistors are connected like branches. This is what parallel combination of resistors. So there are two methods to connect resistors in a circuit. First one, series combination, and the second method, parallel combination of resistors. In series connection, we are connecting the resistors in a circuit one after other. Then in parallel combination of resistors, we are connecting the resistors between the same terminal points, and the resistors are connected like branches. Is it clear? Then you have to study in detail about these two types of connection. First of all, let's talk about series combination of resistors. Or if you look at this picture shows the series combination of resistors in a circuit. Then we have to find what will be the total resistance when we are connecting the resistors in series in a circuit. For that, we know that here we are connecting the resistors one after other. It means between different terminal points. So, the potential difference across each resistor will be different. The potential difference across each resistor gets divided into different values. Then, the current remains same across every resistors. So, in series combination of resistors, potential difference gets divided. That means potential difference will be different and the current remains same. Have you got this? In series combination, potential difference will be different and current remains same. So we have to find what will be the effective resistance when we are connecting the resistors in series. So in series combination, potential difference is different and the current remains same. To find the effective resistance across all these resistors that we have connected in series combination, we are considering these 2 points. That is, in series combination, potential difference is different across each resistor and the value of current remains same. So, the total potential difference through this circuit V is equal to V1 plus V2. Total potential difference V is equal to V1 plus V2. Here, what is the equation to find potential difference using Ohm's law? V is equal to IR. We know that V is equal to IR from the Ohm's law. Then here V1 is equal to, V1 is the potential difference across resistor R1. So here V1 is equal to IR1 and V2 is equal to IR2. So the total potential difference through the circuit is IR1 plus IR2. Here V is equal to IR, that is equal to IR1 plus IR2. Then we have already discussed that when we are connecting the resistors in series combination, the current across each resistor remains same. So here the value of I is same in both sides of this equation. Here we are taking outside this term current. So the equation becomes I into R1 plus R2. So IR is equal to I into R1 plus R2. Then here the value of current is same in both sides of this equation. So R is equal to R1 plus R2. Here is the equation to find the total resistance in the circuit when we are connecting the resistors in series combination. R is equal to R1 plus R2. Then if we are connecting the resistors of same value in this circuit, we have to use another equation to find the total resistance, that is R is equal to NR. Here N is the number of resistors that we are using in the circuit and R is the value of each resistance. Here, if the resistance of same value we are connecting in this circuit, we can use this particular equation to find the total resistance in this circuit, that is R is equal to NR. This N stands for the number of resistors that we are connecting in the circuit and R is the value of a resistor. Is it clear? So here when we are connecting resistors in series, we can find the effective resistance using the equation R is equal to R1 plus R2. Then if we are using the resistors of same value in this circuit, here we can use another equation to find the value of resistance R is equal to NR. Is it clear? So from the equation of effective resistance, we can understand that when we are connecting resistors in series, the effective resistance increases. In series combination of resistors, the effective resistance or the total resistance increases. When we are connecting resistors in series, the effective resistance increases. Is it clear? Then we have to study about the parallel combination of resistors. All of you look at this picture. This shows the parallel combination of resistors in a circuit. There we are connecting the resistors between the same terminal points and we are connecting the resistors like different branches. Then in parallel combination of resistors, there we are connecting every resistors between the same terminal points. So the value of potential difference remains same. Then the value of current gets divided. Here in parallel combination of resistors, potential difference remains same and current gets divided. So in parallel combination of resistors, let me write here, in parallel combination, current will be different and potential difference will be same. Then we have to find what will be the effective resistance when we are connecting resistors in parallel. So we know that when we are connecting resistors in parallel combination, the current will be different across each resistor and the potential difference will be same. So here the total current across this circuit will be I is equal to, total current I is equal to I1 plus I2. Total current through the circuit is I is equal to I1 plus I2. Then we have to find what will be the equation for current using Ohm's law, that we have already stated. I is equal to V by R. We know that I is equal to V by R using Ohm's law. Here V by R is equal to V by R1 plus V by R2, as the value of potential difference remains same. Here, through every resistors, across every resistors, the value of potential difference is same. So here V by R is equal to V by R1 plus V by R2. Then, as the value of potential difference same both sides of this equation, we can write like this: V by R is equal to, we are taking the value of V outside, 1 by R1 plus 1 by R2. Then we are removing the term V from this equation. 1 by R is equal to 1 by R1 plus 1 by R2. Here is the equation to find the total resistance across the circuit when we are connecting the resistors in parallel combination. That is 1 by R is equal to 1 by R1 plus 1 by R2. Then here we are changing this equation like this. Using this particular equation, we are finding the value of 1 by R. So the value of R, total resistance R is equal to R1 R2 divided by R1 plus R2. The total resistance across the circuit when we are connecting the resistors in parallel combination, R is equal to R1 R2 divided by R1 plus R2. Then if we are using the resistors of same resistance in the circuit, we can use another equation to find the total resistance, that is R is equal to R by N. Here this R is the total resistance across the circuit, and here is this R shows the value of resistance of a resistor. Then N is the number of resistors that we are connecting in the circuit. This equation can be used when we are connecting resistors of same value of resistance in the circuit. Here R is equal to R by N. So these are all about parallel combination of resistors. From this equation, we can understand that when we are connecting resistors in parallel combination, the effective resistance of the circuit decreases. So that is the difference between series combination of resistors and the parallel combination. Then we have to discuss about the differences between series combination of resistors and the parallel combination of resistors. In series combination, we have discussed already, the effective resistance increases, and in parallel combination the effective resistance decreases. Then in series combination, potential difference get divided, and in parallel combination potential difference will be same. In series combination, potential difference is different, and in parallel combination potential difference is same. Then about current, in series combination current will be same across all the resistors, and in parallel combination current gets divided. So in series combination current remains same, and in parallel current will be different. Then last point, in series combination of resistors, each resistor cannot be controlled by a separate switch. But in parallel combination of resistors, each resistor can be controlled using separate switch. Let me conclude all the things we have discussed in today's class. There are two methods to connect resistors in a circuit. First one, series combination, and the second method is parallel combination. In series combination, we are connecting the resistors one after other. In parallel combination, every resistors we are connecting between the same terminal points, and the resistors are connected like branches. Then in series, total resistance increases. In parallel, total resistance decreases. In series, potential difference is different. In parallel, potential difference is same. In series, current remains same, but in parallel, current will be different. In series, each resistor cannot be controlled by separate switches. In parallel, every resistor can be controlled using separate switches. I hope you have understood all the things we have discussed in today's class. So that's all for today. Thank you.